The future technological process of invading Mars. Here, introduction. Mars has always been one of humanity's greatest ambitions in the quest to explore and conquer space. Since the early 21st century, major space agencies such as NASA, ESA, and CNSA, and private corporations like SpaceX have invested significant resources into studying and developing the necessary technologies for reaching and potentially colonizing Mars. However, the idea of invading Mars extends beyond simple exploration. It involves establishing a human presence, controlling resources, and potentially asserting military dominance over the planet. The term invasion can be understood in two different contexts. First, there is the military invasion, where a nation or even an extraterrestrial force might assert control over Mars for strategic and security reasons. This could involve the deployment of military assets, robotic defenses, and AI-driven command centers to maintain dominance over the Martian landscape. The second interpretation is colonization and resource exploitation, where humanity seeks to transform Mars into a livable environment through technological advancements, terraform the planet, and extract valuable resources. For such a mission to be successful, humanity would require highly advanced space transportation systems capable of ferrying large populations and equipment. Artificial intelligence and robotics would play a crucial role in the construction and maintenance of settlements, while advanced weaponry might be necessary for defense against unknown threats. Additionally, terraforming technologies would be essential to modify Mars's harsh environment and make it habitable in the long term. Although this scenario may seem far-fetched, rapid technological advancements suggest that a large-scale Mars invasion or colonization effort could become a reality within the next century. This article will explore the critical steps required for such an endeavor, from technological preparations and landing logistics to infrastructure development, resource utilization, and overcoming the immense challenges of colonizing Mars before ultimately assessing the potential future of human expansion beyond Earth. 2. The steps of a Mars invasion. 1. Technological preparation. To successfully invade and establish control over Mars, humanity must first develop a highly sophisticated technological framework that ensures transportation efficiency, survival capability, and strategic dominance in an unpredictable extraterrestrial environment. The first step in this process involves the development of advanced space transportation systems. Spacecraft such as SpaceX's Starship or nuclear-powered propulsion systems would be crucial in transporting large numbers of astronauts, military personnel, and robotic assets to Mars. Additionally, in-orbit refueling and the utilization of local Martian resources to produce fuel would be key in sustaining long-term missions while reducing dependency on Earth. Artificial intelligence, AI, and robotic systems would also be integral to both military and colonization efforts. Autonomous robots would be deployed to survey the Martian surface, construct facilities, and secure territory. AI-driven systems would manage logistics, monitor environmental hazards, and assist in combat scenarios if required. Moreover, survival technology would be paramount. This includes closed-loop air and water recycling systems, sustainable food production methods such as hydroponics and aeroponics, and the construction of self-sustaining habitats using 3D printing technology with Martian soil. Furthermore, advanced weaponry would be required to safeguard any Martian settlement. This could include laser-based defense systems, electromagnetic pulse, EMP weapons, automated drone fleets, and AI-controlled military outposts that ensure security against extraterrestrial threats or possible human conflicts over Mars' valuable resources. 2. Landing on Mars. The process of landing on Mars presents a significant challenge due to the planet's unique atmospheric and gravitational conditions. With gravity at only 38% of Earth's and a thin atmosphere that provides limited braking capability, safe descent requires precision-engineered technology. The first phase of the landing process would involve the deployment of autonomous landing craft, tasked with preparing the Martian surface before the arrival of human crews. These robotic units would establish communication networks, conduct geological surveys, and set up perimeter defenses. Once the site is secured, satellites and drones would be deployed for real-time monitoring and navigation. These systems would continuously scan the terrain, assess weather conditions, and locate the most optimal sites for future settlements. The landing itself would be executed in multiple stages, beginning with robotic cargo missions, followed by the gradual arrival of human crews, who would oversee the construction of initial outposts and ensure operational stability. The establishment of safe zones is critical, as Martian dust storms, temperature extremes, and potential radiation exposure pose significant threats to early settlers. 3. Establishing infrastructure. Upon successful landing, the immediate focus would be on constructing long-term infrastructure to support human life and potential military operations. The first step in this process is selecting a suitable location for settlement construction. Regions near subsurface ice deposits or naturally occurring cave systems would be ideal, as they offer potential sources of water and protection from cosmic radiation. To ensure sustainable habitation, pressurized domes and habitats would need to be constructed using locally available Martian materials. These structures could be built using 3D printing technology and reinforced with radiation-resistant composites. Energy generation would also be a primary concern, with high-efficiency solar panels serving as the main power source, complemented by compact nuclear reactors such as NASA's kilopower to provide a stable energy supply. Advanced battery storage systems would be essential for maintaining power during dust storms or periods of low sunlight. Additionally, a sophisticated communication infrastructure would be required, involving Mars-orbiting satellites to maintain connectivity with Earth. AI-driven systems would oversee colony management, automating life support systems, security operations, and logistical planning to ensure operational efficiency. 4. Terraforming and resource utilization. For long-term habitation, Mars must either be adapted to human physiology or its environment must be altered through terraforming. One of the first steps in this process would be introducing oxygen-producing microorganisms such as cyanobacteria, which could gradually convert CO2 into oxygen. Over time, genetically engineered plants could be cultivated within enclosed biodomes and, if successful, introduced into the external Martian environment. Increasing Mars's temperature is another key step, as its current climate is too cold to support stable human settlements. This could be achieved by introducing greenhouse gases, such as CFCs, to thicken the atmosphere, or deploying orbital mirrors to reflect and concentrate solar radiation onto the planet's surface. Meanwhile, resource exploitation would provide immediate benefits to settlers. Water ice deposits located at Mars's poles could be harvested for both drinking water and hydrogen fuel production. Martian soil contains valuable metals and minerals such as iron, aluminum, and silica, which could be processed to create building materials and solar panels. By utilizing the Sabatier reaction, settlers could synthesize methane fuel from CO2 and hydrogen, creating a sustainable energy supply for interplanetary transportation. 3. Challenges of a Mars invasion. Despite significant advancements in space technology, invading and colonizing Mars presents a wide range of formidable challenges. These challenges include environmental hazards, logistical difficulties, geopolitical tensions, and even ethical considerations regarding planetary expansion. If humanity is to establish a presence on the red planet, these obstacles must be thoroughly examined and systematically overcome. One of the most immediate and critical challenges is Mars's harsh environment. Unlike Earth, Mars lacks a strong magnetic field, meaning its surface is bombarded by dangerous levels of cosmic and solar radiation. Without adequate shielding, prolonged exposure could lead to severe health risks, including cancer and genetic mutations. Future Martian settlements would require radiation-proof habitats, possibly built underground or covered in thick layers of Martian regolith. Additionally, Mars's average temperature of -63°C can drop to as low as -125°C at night, making it one of the coldest places where humans have ever attempted to settle. Maintaining habitable temperatures within outposts would require significant energy resources, further complicating long-term sustainability. Another major issue is the thin atmosphere and low pressure on Mars. The Martian atmosphere is about 100 times less dense than Earth's and consists mostly of carbon dioxide, making it impossible for humans to breathe without life support systems. This also presents challenges for creating pressurized environments for habitation. Any structural failure in a habitat could result in immediate decompression, making leaks or damage potentially fatal. Unlike Earth, Mars does not have liquid water on the surface, meaning settlers must extract ice from underground deposits and purify it for consumption and industrial use. Beyond environmental hazards, logistical difficulties represent another significant obstacle. Due to the vast distance between Earth and Mars, sending supplies and reinforcements would be an expensive and time-consuming process. The shortest travel time to Mars takes about 6 to 9 months, and launch windows only occur every 26 months when the two planets align favorably. This means that Martian settlers must be highly self-sufficient, as relying on resupply missions from Earth would be impractical. All essential resources, including food, water, air, and fuel, must be produced or recycled locally, requiring the development of robust closed-loop life support systems. Furthermore, political and military conflicts could emerge as humanity expands beyond Earth. If multiple nations or private corporations attempt to establish control over Mars, disputes over territorial claims and resource exploitation may lead to geopolitical tensions. The absence of any official governance structure for Mars means that conflicts could escalate if not properly managed. The potential militarization of space also raises concerns about whether nations might deploy weapons on Mars for defensive or offensive purposes. If Mars is to be colonized, an international regulatory framework would need to be established to prevent conflicts and ensure fair resource distribution. Finally, the ethical implications of invading Mars must be considered. If microbial life exists on Mars, human expansion could pose a threat to its survival. There's an ongoing debate in the scientific community about whether humanity has the right to alter or terraform another planet, especially if it risks contaminating or eradicating potential extraterrestrial life. Some argue that Mars should be preserved for scientific study rather than exploited for human use. Others believe that colonization is necessary for the long-term survival of our species. Regardless of the approach, ethical guidelines must be established to balance human expansion with planetary preservation. 4. The future of Mars invasion. Looking forward, the invasion and colonization of Mars could unfold in two very different scenarios, one optimistic and one pessimistic. The outcome depends on technological advancements, global cooperation, and the successful resolution of the challenges previously discussed. In the worst-case scenario, the mission to invade and colonize Mars could fail due to technological, environmental, or political factors. A major obstacle could be the inability to establish a self-sustaining colony. If essential resources such as food, water, and oxygen cannot be reliably produced on Mars, settlers would remain dependent on Earth, making long-term habitation impracticable. Additionally, unforeseen ecological or engineering challenges could derail plans for terraforming, leaving Mars uninhabitable for the foreseeable future. Another possible failure scenario involves conflicts between nations or private corporations. If multiple entities claim the same Martian territories or resources, competition could escalate into interplanetary disputes. Without proper governance, disagreements over land ownership, mining rights, and strategic positioning could result in conflicts that mirror historical territorial disputes on Earth. The prospect of space warfare, whether through military force or economic sabotage, could hinder humanity's ability to maintain peace and cooperation on Mars. Furthermore, if extraterrestrial life is discovered on Mars, it could lead to ethical dilemmas or even existential threats. While it is unlikely that intelligent life exists on Mars, the presence of microbial life could still pose risks to human settlers. There is a possibility that Martian microbes could be harmful to human biology, leading to unknown diseases or infections. On the other hand, humans might inadvertently introduce Earth-based microorganisms to Mars, potentially wiping out native Martian life and contaminating scientific research efforts. If such conflicts arise, it could result in the abandonment of colonization efforts or force humanity to reconsider its approach to planetary expansion. However, in the best-case scenario, Mars could become humanity's second home, offering a new frontier for scientific discovery, technological innovation, and interplanetary civilization. A successful colonization effort would require a self-sustaining settlement with millions of inhabitants, advanced life support systems, and a thriving economy built on space resource extraction. If these conditions are met, Mars could serve as a stepping stone for further human expansion into the solar system. One promising outcome is that Mars could serve as a training ground for interstellar travel. By mastering the challenges of living on another planet, humanity could gain the knowledge and experience necessary to travel even farther, possibly to moons like Titan or Europa, or even exoplanets beyond our solar system. Colonizing Mars would push advancements in propulsion systems, artificial intelligence, medicine, and resource management, paving the way for future deep space missions. Additionally, terraforming efforts could eventually transform Mars into a more Earth-like world. While this process would take centuries or even millennia, technological innovations in atmospheric engineering and climate control might one day create a breathable atmosphere, liquid water oceans, and a stable ecosystem on Mars. If successful, this would allow humans to live on Mars without relying on pressurized habitats or artificial oxygen supplies, effectively making it a true second home for mankind. A successful Mars invasion and colonization could also inspire a new era of space exploration and cooperation. If humanity unites under a shared goal of expanding beyond Earth, the space industry could witness unprecedented collaboration between nations, corporations, and private individuals. The economic benefits of mining asteroids and developing interplanetary trade networks could also fuel economic growth, creating entirely new industries and job opportunities in space. The conclusion: the invasion of Mars is no longer a question of if, but when. Technological advancements have made it increasingly feasible for humans to reach and colonize Mars, but the challenges remain immense. While the risks include extreme environmental conditions, logistical difficulties, and potential political or ethical conflicts, the rewards could be even greater. Successfully establishing a presence on Mars would mark the beginning of humanity's journey as a truly interplanetary species. The question we must ask ourselves is not whether we can invade Mars, but whether we should. If humanity chooses to embark on this mission, it must do so with careful planning, ethical responsibility, and long-term sustainability in mind. Mars represents an opportunity for both scientific discovery and human expansion, but it also carries significant risks that must be carefully managed. If the endeavor is successful, Mars could become the first of many human settlements beyond Earth, leading to the eventual colonization of the solar system and even other star systems. However, failure could mean the loss of vast resources, human lives, and the potential abandonment of interplanetary ambitions for generations to come. The coming decades will determine whether Mars will be humanity's next great conquest or remain an unreachable dream. Regardless of the outcome, the exploration of Mars represents one of the most exciting and ambitious challenges in human history, shaping the future of our species in ways we can only begin to imagine.